Hello, welcome to Code Design. Today we'll be solving LeetCode 1752. Check if array is sorted and rotated. So let's read the problem. Given an array nums, return true if the array was originally sorted in non-decreasing order. Then rotated some number positions including 0. That means the array can rotate, the array may not rotate, just sort it. Otherwise, return false. And the array may contain duplicates. So there is a note here. We'll go through this note. So let's look at the example. So 3, 4, 5, 1, 2 is our input. And this input looks like this is sorted and rotated. So if it is sorted, what would be our sorted array? That would be 1, 2, 3, 4, 5. So how many times these array rotated? These array rotated starting from position 3. It rotated 3 times. So how it rotated? It did a right rotation. So 5 came here, and then 4, 4 came here, then 3 came here. So we have remaining 1 and 2. So 5 had a right rotation, and then 4 had a right rotation, 3 had a right rotation. So 3 positions, right? And here is the observation here. If an array is sorted and rotated, how the indexes changes, right? So here, if you see in the original array, 1 in 0 position, and how many rotation was there? 3 rotation. So 0 plus 3, right? So 0, 1, 2, 3. In this rotated array, index position of 1 is index 3. So 0 plus 3. In the original array, index of 4 is 3, and if we add 3 with 3, so 6. So in the new array, is index would be 6, right? But we have 5 element. So that's what it is saying, that we need to take a mod with the size. So 3 was, if index in the original array is 3, the size x rotation size is 3, so 3 6, and then we take a mod with 5, which equals 1. So in the rotated array, index of 4 is 1. So this is how you can relate element from the original array to the rotated array. So that is true for all the elements. Like for 5, it would be one more, right? So index of 5 is here 4. Here index of 5 here is 2. So again with 4 plus 3, 7, and then mod 5 equals 2. So it's 2. So let's see how we can solve this. So one of the approach, what if I'm not discussing any ON square solution, brute force solution. Let's discuss all the four N solution, ON solutions. So I will show 4 different way code, two ways. So 3, 4, 5, 1, 2. So this is the rotated array. What if we add this 3, 4, 5, 1, 2 at the end of this array? Like we create a new array with 2n space, 2n space, and copy the array here. So that would be our array. What you can see, our original array was 1, 2, 3, 4, 5. So it exists in this new array. So now, what you can see, it translates to a sliding window problem. So what you see for each of the element, if we look through from here to this one, right? Each of the element we need to see if we have a non-decreasing order. So here up to this we had a non-decreasing order of element 3, but here we see that it is decreasing. So we set the counter to 1 because one element is a length 1, right? We just set the counter to 1 and again see how far we can go with a non-decreasing element. So here we can see we can go all the way up to 5, and that is our size. So while we are looping, we need to check if our window size, right? This C count 1 is count equals our n. So here we'll get a count equal n and we'll return. So this is one way, but if you see, I'm saying we are looping and using extra space, right? So extra n space we'll be using. So actually, we'll be using total 2n space if we copy this rotated array, 2n space. So how we can not use any extra space using the hints here, the note here, the relation, right? What I just discussed, that we can take the mod. So how we can do it? So when we are comparing two element I minus 1 and I, right? I minus 1, we are comparing with num of I minus 1 to num of I. When we are doing it, what if we take a mod of n? If we take a mod of n here and also mod of 10, I percentage n here, then this problem solved. We don't need to actually create a new array with copying all the elements in the new array. It will still work because it will translate to according to the relation. So this is one solution, which is according to the hints. Just you, but your loop still has to be 0 to, you don't use additional space, but still you initialize a loop I equals 0 and I less than 2n, and then you check for each element if they are non-decreasing. If you find a element which is actually decreasing, then you set the counter 1. Otherwise, you keep including counter. When the counter is 5, here is 5, which is n, you return. So this is two way. One way is additional space. Another way 3, 4, 5, 1, 2. What we'll do in this approach? We'll find the portion that is sorted. We'll find the pivot and we'll find this part. And we'll check if this part is sorted and this part is sorted. And when we do this, then this one must be, these three must be greater than these two, right? Because if it is rotated, then it has to be the element at index 0, uh, last index, right? N minus 1, 4, index 4. It has to be greater than this. And we need to just find out this part is sorted and this part is sorted. What if the array, original array and the sorted array is the same? That means if the array is not rotated, in that case, we'll just return it true with a single pass. So let's write the code. We start with integer I equals 1 for while I less than length and nums of I greater or equals nums of I minus 1. So here, right, nums of I must be greater or equals I minus 1. So when this condition satisfy, we will increment I. So in that way, I will be initially 1, and it will compare with I minus 1, which is 0, and 3, 4 is greater than 3. So we'll go to the next iteration where I will be 2, and then I minus 1 is 4. 4 is less than 5, right? 5 is greater than 4, so that is okay. But for the next one, when I equals 3, then actually this condition doesn't satisfy. So it will exit from the loop. This is for this use case. What about this use case when array is sorted but not rotated? In that case, actually, I will keep incrementing all the way up to the last element. And then there is no rotation. We can return I here from here. So let's check the condition here. If I equals num.length, return true, return true. So that means here array is sorted, not rotated. And the another condition, as I said, this one, nums of 0 if less than nums of nums dot length minus 1. If that is the case, if this one less than this, then return false. Otherwise, we have the rotation and say integer j equals I. I is our rotation index. Now, this part we need to check if this is increasing order, right? Or non-decreasing order. So while j plus 1 less than nums dot length, if nums of j plus 1 less than nums of j, then return false. If nums of j plus 1 less than nums of j, then we'll return false. Otherwise, we'll return true. Okay, we need to increment j and let's run this. Okay, it passed the test cases. So this problem, I solved it in a contest. There was a contest, and there was so many wrong answer because the approach I took. So this is the approach that was accepted in 2021 December. It beats 100%, took 0 millisecond, and even memory beats 100%. And this is the same code that I coded here. So we find the non-decreasing elements, and then if we reach at the end, we say we return true because the array is sorted, and then we check this condition, and we do this. So this was very efficient and clean code. And the last one I will show. This is still ON, but this is like a complicated way. I had to handle lots of test cases. But if you have interest, just see how sometimes you come up with some approach. So yeah, you see that it had so many test case failure in a contest mode, right? So here I declare a variable rotation found equals false, and then from I to nums dot length, what I do here, um, if I plus one less than nums dot length and nums I less or equals nums of I plus one. Again, this comparison, right? If it happens, then we do nothing. That means if it is increasing order, like three, okay, three, four, five, one, two. So up to three, four, we don't do anything. And then for five, I plus one is one. So, and five is greater than one. So we come to the else. On the else section, what we check, this five actually has to greater than two. If not, then we return. And and if this is not the case, then that means there is a rotation found, because here is a rotation, right? We got a rotation. So rotation found initially false. So rotation found will be false here, and we'll move to the yeah, rotation found will be false here. And then what we do, rotation start index. So we assign the rotation index start index. So our I is 5, so rotation start index would be this one, index 3, which is 1. We set the rotation start index and we say rotation found equals true. Then we come to this loop. So though it was accepted in the contest, but I can see now there is a bug when I was revising it here, though passed all the more than 100 test cases. So this rotation start index has to be out of this loop. Otherwise, you see whatever we set here, rotation start index, it is getting to be 0 here. So it should be outside of the loop. Now, what it is doing again for 1 and 2, if it gets there, it is good. It will return true, right? It will not go to the else sections, because 1 to it is non-decreasing order. But what if there was something 1, 2, and again 1? If that was the case, it would come here, it would check this condition, and now rotation found would be true. If rotation found is true, then what we do, if there is a rotation found, then from here to the rotation found, everything should be non-decreasing order. So we set j equals 0 and we look through j less or equals rotation start index. So rotation start index would be here 3, whatever we did, and we check if num j equals nums dot length minus 1. So that means if it is increasing order, then it is good. If it is not increasing order, right? If j is less than j minus 1, then we return false. Otherwise, we return true. So that was my solution on the context, but it works. It perfectly works. We need to get this rotation out of this one. But yeah, I wouldn't recommend this approach. This is convoluted. Will easy to fail the test cases, but just wanted to show that a different way, right? So all of the solution is ON. And time complexity is ON for all of them, and space complexity is constant, which is O. First one, space complexity, is ON, and for the remaining three, space complexity is O1. So I hope you like it. Let me know if you like this or not. Thank you.